All right, I'm going to talk through right now the 2008 number 6 question. I believe as far as we got in class was through the plan. So the question is asking about perform a test to determine whether students who attend the magnet school demonstrate a significantly higher mean difference in test scores, post-test minus pre-test, than students who applied to attend the magnet school but who were not selected and then attended the original school. So again, today in class we are practicing, well, how do we know what test we're going to use? It is helpful to know what test we're going to use right away, because in the state part you have to state your hypotheses. If you don't know what test you're going to use, you're kind of up a creek for how you're going to state your hypotheses. So we got all the way up to the plan part, and we talked about how we do have to actually plot what's going on, and we never did get to do that. So I went ahead and I took the data for the original school and I plotted the differences, because that's what we're looking at, and you can see that in the problem. Okay, and we're looking at the differences. It says it right here, as well as right here. And you can see both of them are symmetric. Actually, both of them are they're pretty symmetric. We don't even really need to say symmetric enough. They're symmetric enough where we can proceed. You want them to be higher than 15. If they're higher than 15, you can have a skew. If they're lower than 15, you really do want it very symmetric. From there, we name our method. Okay, again, we say how many samples. We have 2 samples. Are we dealing with a T or a Z? We're dealing with a T because we're dealing with averages. Is it a test or an interval? Well, it tells us to do a test. And then because it's 2 samples, mu of O, which stands for the original, minus mu of M, which stands for the magnet. And we want to see if the students who applied to attend the magnet school, the students who attended the magnet school, let me highlight this. Demonstrate a significantly higher mean difference in the test scores. Well, the way we set it up with the original versus the mean, we needed to make sure it's the mean of the original is less than the mean of the magnet. And that is actually the same as the magnet school being higher. So we're now, after we did the plan, we're at the do part. I'm going to just slowly bring this down. Oops. So you can see the normal curve that I have here, and always when you put that normal curve, whenever you're doing a 2-sample t-test or a 2-sample z-test, in the middle you will always have 0. You assume in your null hypotheses, your center is always whatever that null is. There is no difference here. And if there's no difference between them, when you subtract them, you're going to get 0. The standard deviation, just a friendly reminder, if you've forgotten what the standard deviation will be, you get the formula on your formula chart. Go to 2-sample standard deviation for means. Pause this and look for this now if you need help with that. Okay, so they give us 3.977 squared, and I don't believe I have the original, I don't have the original data that they gave us. But if you look at the column that give you the standard deviation, 3.977 squared over 12, because that's my sample size. And I stuck with the original school first, okay? And then I have the magnet school here. 9.407 squared divided by 8 and take the square root. What did I do next? Well, I said, well, what's my statistic? My parameter, what the population is about, is my mu. My statistic is what's going on with the sample, and those are our X bars. Whoops. Okay. If you look at this, you see they give this to us now, 3.0 minus 11.750. X bar of my original minus X bar of my magnet. And again, I stayed consistent to what's going on with my null hypothesis, how I'm writing this. Now, I want my magnet to be bigger. I already have evidence that the magnet is bigger. That's what we're trying to find a difference for. That's what we're trying to find evidence for. The rest you can now plug into your calculator. Be one with your calculator. Go to your 2-sample t-test. Your X1 is going to be your original here. Your N1 is your 12, and then your standard deviation of 1 is 3.977. If you're not doing this with me, you need to become one with your calculator. Pause it and grab your graphing calculator. Next, your X bar of 2 will be 11.750. Your N2 is 8 because that's the sample size for the magnet school. And then the standard deviation for the magnet school is 9.407. You are not pooling, you only pool for proportion, and then you just need to make sure that you highlight the less than. Once you get all that, they're going to give you a T-score. Now you need to show your work for T. Pause it right now and see if you can show your work for T on your own. For T, you should have gotten now your statistic, your observed times observed minus the mean divided by your standard deviation, and you don't need to rewrite that out. As long as you have it labeled sigma, you can just put sigma down there. We get a T-score. Oh, and I didn't write mine down. I don't have my calculator in front of me, but that's okay. And I get a p-value, and now we can draw a conclusion. We have good evidence. And so let me get rid of that. Here's my conclusion. Now, before you write it, pause it and see if you can do it on your own. I know I have it up here, but don't cheat. Practice it on your own. And you guys have gotten really good at your conclusions. You should have written, because our p-value is approximately 0.0177, which is less than alpha of 0.05. We reject the null hypothesis. We have evidence that the true average test difference for kids at the magnet school is greater than the kids at the original school. Now, if you want to state it the other way around, the original school is less than the one for the magnet school, that's fine as well. It's stating the same thing. So this is all of just part A, and we have to get through D. Part B is what we just talked about, and you can see right away they give you an output. I'm guaranteeing you're going to see that somewhere on the test. Just a friendly reminder that right away you should be looking right over here. The constant, the coefficient that goes with it is always your y-intercept. Your slope is right below right here. And then they always tell you what the x variable is there, the pre-magnet score. And that's your slope, okay? And I just highlighted again your y versus x. And then we have it for the original down here as well. Your y-intercept, your x variable, so the pre-test for the original, the slope. And you can notice here again, you have your standard deviation of your residuals. You have your r squared, and just a quick check, I've said this many times, but to find your r, you take the square root of this decimal. So the square root of 0.025 and the square root of 0.788. And then you need to assign a positive sign to it or a negative sign, and you do that by looking at the slope if you don't have any data. You have your t-score right here at 0.40 and your p-value of 0.706, a t-score of 6.09, and a p-value of 0. That is for a one sample t-test for the true slope. You have the standard deviation of the slope. What is that for? That is for a one sample t interval for true slope beta. And then finally, we have this graph, and we have the question B. Question B is saying, state the equation of the regression line for the magnet school and interpret its slope in the context of the question. 2 is state the regression line for the original school and interpret its slope in context of the question. And you can see I color-coded it here. And I wrote it down in terms of y and x. Okay, my post-magnet school, right here, y, is equal to, okay, the predicted post-magnet school is equal to 73.27 plus 0.811 times the pre-magnet score. And I have that right here in red. And then it does say interpret the slope in context, something you need to have memorized, and I'll have that on flashcards for you as well. The model suggests that the slope is approximately 0.1811. This means the predicted post-magnet score, the change in the y, will increase by 0.1811. You would change this word to decrease if it was a negative slope. It will increase though by by 0.1811 points for every 1 unit in X, and that needs to be in context. So for every 1 additional point scored on the pretest. All right, and then we get to the blue. If you go up here to the blue up here, again, our Y, our post-original score, our predicted post, okay, is equal to my Y-intercept 9.24 plus 0.9204 times the pre-original score. Okay, now what does that slope mean? It's the predicted, and if you don't have predicted, you're going to be docked a point. It's the predicted post score for the original school will increase by 0.9204 points. So that's the change in Y, your rise over your run, right? So your rise is here for each additional 1 unit, each additional point scored on the pretest at the original school. So you can see my wording's a little bit different, but it's all the same outline. You're talking about the predicted Y will change by the slope for every 1 additional X unit. Next, part C. Get it to a color I like here. All right, now we're talking about a slope test. We have not had a lot of practice with this. Please pause it right now and try it on your own using your notes, because we haven't practiced it enough, I think, to have it memorized. So use your notes. Part 1 says, use the regression output, state the p-value and conclusion for this test at the magnet school. Assume the conditions for inference has been met. So what they're asking you to do right now is, this part is the state part. You need to tell me what the p-value is. That's in this, I'm sorry. Let me back up, I'm going too fast. Your null and your alternative, there's your state. The conditions are already done for us. That's the plan with the method. Excuse the bell here. Then we have our state part right here. That screwed me up again. Let's try that one more time. Forgive me. Give yourself a good chuckle. Here's my state part. Here's my plan part. Here's my do part. Give me the p-value. And here's my conclude. You go back, you can see right here is our p-value for the slope of the magnet school. Okay, if we put that under a test. And here's my p-value for my slope of the original school. What does that mean? We always assume that there's no slope. That when we got this data, just by chance it went positive, or just by chance it went negative. How do we know for sure it's always positive? We have to perform a significance test on slope. So what do? I get my p-value. Because our p-value is approximately 0.706, which is greater than alpha, we fail to reject this null hypothesis right here. We have no evidence for HA that there's a correlation between pre and post-test scores at the magnet school. Part B, because the p-value is approximately 0, again, you see that right here. For my slope, which is less than alpha is equal to 0.05, we reject our null hypothesis. We have evidence that there is a correlation between pre and post-test scores at the original school. And then finally, part D, let's see if I can do it before the bell rings. Part D is really getting at just, can you look at a graph and draw some conclusions? You don't need to be a psychologist here. You don't need to be the most famous AP statistician. You just need to use some problem solving skills and look at this graph. They gave you a graph for a reason, and I know if you read this, they say anything else on the regression analysis. But we haven't even used the graph yet, which should be an indication for you that you need to look at this graph. And we can write some notes on this, okay? We can look at this and we can say, well, look right here. What do you notice the difference between these low scores? And I'm gonna deem the low scores between 60 and 70. So between 60 and 70, you can really note that the magnet school, the low scores, they were really a lot higher. But the original schools, they increased at a faster rate, okay? But overall, the magnet school, they just did better, okay? It didn't really matter what their pretest score is. They all had really high scores. In fact, they had higher scores than the people who did pretty well on their pretest score, up until the very highest at around 85. How did I sum this up? I summed this up nicely by stating, overall, the two schools' pretest and post scores, it appears that the students with low pretest scores, I will state anywhere in the 60%, signifies a low test score. Well, they benefit from attending the magnet school compared to the original. So again, I am stating here that these people with the low test scores, they benefit by going to the magnet school, okay? Next, what do I say? But also, students with low pretest scores performed better on the post-test than students with higher pretest scores at the original school. And you can see that again. Whoops, sorry about that. They did better than the people with the higher pretest scores even. So what did I say? I then went on to say, at the original school, only students who scored very high in the pretest scored very high in the post-test. Overall, it appears that if you attend the magnet school, you have a pretty high post-test score no matter how you did on the pretest. Again, I'm just really analyzing this graph to the best of my ability, what's going on, using language that hopefully everyone can understand. Pause it right now, write this all down, and then go back and look at your writing and reanalyze the graph and make sure you can really understand that graph, what I was saying there in words, what's going on with the entire situation. I hope this helped. I hope you're listening and you're working hard for that AP Stats test. I'm proud of you guys. Take care.